Hello, you fine people of YouTube. I've had this course up on nativescripting.com for a couple years now. I keep it updated, of course. So this is the Getting Started with NativeScript guide, and this is the core version. This is a free course that's available on nativescripting.com. So I'm posting part of that course, the most recent updates, right here on my channel, just so that more people can be aware of it. Most of my tutorials, as you know, on this channel, a little bit more intermediate to advanced level. I do lots of tips and tricks and help people out. But this year, I'm trying to help out more folks in the NativeScript community, people that are just getting started with it. So in order to make this course quicker and more accessible, I'm posting most of it here on this channel right now. Now, of course, when you're watching it on NativeScripting, you have your progress tracking and you have each individual lesson split out. Here, everything is just going to be one long video. And if you like what you see, go to nativescripting.com. There's links down below. You can sign up and watch the free course there. You can also watch the free NativeScript with Angular course there, the Getting Started one. And there's a couple of other free courses there. Now, when you're done with the free courses, make sure you check out the premium courses. There's advanced NativeScript courses there as well. And there's coupons down below in the description. By the way, if you are into NativeScript with Angular, you can still watch this free NativeScript Core course because all the widgets that we're going to be using and all the concepts are pretty much reused in the NativeScript with Angular course. But if you like this structure, if you like this content being posted on YouTube and you really are into Angular and you don't want to watch anything else, let me know down in the comments below and I can try to make this happen for the NativeScript with Angular Getting Started guide as well. I'll post it here to YouTube as well. Otherwise, I just want to say that this is a longer video. So if you don't have a coffee yet, make sure you go grab one. I got mine right here. Get your editor ready. Make sure you have a functional NativeScript environment set up with either iOS emulator running or Android emulator, but make sure you have the NativeScript CLI workflow set up. If you don't yet, then you can check out my other videos. I'll link to them down below as well on how to get your Mac environment set up or how to get your Windows environment set up to have all that ready and ready to go to take the courses. All right, enjoy the course. Are you as excited to get started with this course as I am? Well, before we dive in, there's a few things we need to cover. We need to talk about what is NativeScript exactly, and what are some of the prerequisites for taking this course. We'll also talk a little bit about the installation and what that entails. So what is NativeScript? It's a free and open source framework for building native iOS and Android apps using JavaScript and CSS. NativeScript renders UIs with the native platform's rendering engine, so there are no web views, resulting in native-like performance and user experience. NativeScript provides a best of both worlds development experience. The NativeScript cross-platform JavaScript modules give you the convenience of writing iOS and Android apps from a single JavaScript codebase, while the NativeScript runtimes give you the power of accessing native APIs, SDKs, and frameworks when you need them, all without needing to open Xcode or Android Studio. This guide assumes that you have some basic knowledge of JavaScript, CSS, and your development machine's terminal. More specifically, you should know basic JavaScript concepts such as how functions, if statements, and loops work. You should know how to write simple CSS selectors and know how to apply CSS rules as name-value pairs. You should know how to open a terminal or command line prompt on your development machine, how to change directories, and how to execute commands. Finally, you should also know the basics of your text editor or IDE of choice. You can use any text editor to build NativeScript apps. However, for the best possible experience, you may want an editor with built-in TypeScript support if you're going to be using TypeScript, such as Visual Studio Code. In order to start this tutorial, you'll need to have the NativeScript CLI, or the command line interface, installed on your development machine, which you can do by going to the documentation website and then in the introduction section, click on the installation link. Here you'll be guided through installing Node and all the other prerequisites that you need to get started with NativeScript, including the NativeScript CLI. Setting up your machine for native development can be tricky, especially if you're new to mobile development. If you get stuck or if you have any questions while going through these instructions, the NativeScript community forum is a great place to get help. Now with that out of the way, let's get started building apps with NativeScript. In this chapter, you're going to start with the basics, including creating a new app, getting that app to run on emulators, and setting up a development workflow that will allow you to create apps quickly. So in this chapter, we're going to be learning about creating apps, running the apps, debugging the apps that you've created, and I'll recommend an editor for you to use if you don't already have one. In NativeScript, you create and run apps using the NativeScript CLI. After installation, the NativeScript CLI is available on your terminal or command prompt as a TNS command, which is short for Telerik NativeScript. In this section, you'll familiarize yourself with the NativeScript CLI and use the CLI's create command to start your first NativeScript app. Open your terminal or command prompt and run the following command to create a new NativeScript application. Here you're passing two things to the create command: hello world, which determines the name of the app you're creating, and the --template option, which tells the NativeScript CLI to scaffold an app using a predefined template named NativeScript Template Tutorial. You can use the TNS create command to scaffold apps at a variety of different starting points. The NativeScript Template Tutorial template creates a dead simple app for the purposes of teaching the basics of NativeScript. The create command will take a minute to complete, as the NativeScript CLI needs to download a few dependencies while setting up your new app. When the command finishes, use the cd command to change directory to navigate into your new apps folder. Now that you've created a new app, let's look at how to get your new app up and running in an emulator. At any time, you can run the TNS help command to view your NativeScript CLI's help documentation in your web browser. Now that you have an app scaffolded on your local computer and you have CD'd to the root of the app, you're ready to run your application in an emulator. In NativeScript, you use the CLI's TNS run command to run your apps on iOS or Android. Let's start with Android. Execute the following command on your terminal to run your app on an Android emulator. Now, you might see an error like this one. It says the current application is not compatible with NativeScript CLI 6. And the reason for this error is because the template that we used, the template that has all our tutorials set up, is actually a template that uses an older version of NativeScript. And I wanted to show you this because sometimes you might find templates out there that might not be compatible with the latest version of the CLI. So this is a good place that I thought I'd show you this issue and how you can go around it. So I'm going to open this up in Visual Studio Code real quick, just so that I can show you the project and package.json. This is the file with TNS Core Modules 4.1.0. And right now, if I check the version of the NativeScript CLI, you'll see that we have version 6.4.0. So we need to migrate the old project generated with the old template to the new TNS Core Modules. I'll explain what those are in a minute. But for now, let's just do the migration. And this tells you exactly what you need to do right here. It says you need to use the TNS migrate command. So I'm going to say TNS migrate, and this will clean out the old dependencies and add the new ones. Now that it's done, let's take a quick peek at the project, and you'll see that now in package.json, we have TNS Core Modules 6.0.1. Great, let's move on. So I'm going to issue that command again, TNS run Android, and continue on. Now you should not get that error, but we get this message saying, improve your app by switching to market mode none. This is an Android optimization. And you can choose yes or no here. It doesn't matter at this point. For our learning purposes right now, we just want to get past this. So yeah, I'm going to go ahead and accept the default and press enter here. At this point, the CLI will automatically find my Android emulator that I have installed and configured on my system and kick off the build process and then install the native application that we've built on that emulator and run it. All that stuff is done automatically for you by the CLI. If you get a failure at this point, that means that something might be wrong with your Android setup on your local machine. I do have two YouTube videos, one for Windows setup and one for Mac setup, on how to configure your environment for native development, including the Android environment setup with the emulators. I'll link to those videos down below. Now, because we are using an older template here, we did get another error, and it's a type error. It says application module start is not a function. So if you come across this one, that's an easy fix as well. Open up your app folder and then app.js And then right here, we're calling application module start. But this is an old API. The new API is application run. Go ahead and make that change. And let's issue the command tns run Android one more time. Now this time it's not going to take as long because the Android packages is already built. So the app is going to start right up. If you're on Mac OS and would prefer to develop on iOS first, you can type Control-C in your terminal to end the previous tns run Android command, and then execute the following command instead, tns run iOS. NativeScript uses Xcode under the hood to build and run iOS apps, and Xcode is only available on Mac OS. Therefore, you can only run iOS apps on Mac OS. The run command will again take a few seconds as the NativeScript CLI will be building and deploying a native iOS application. When the command finishes, the native emulator will open and you will see your app. You might have noticed that the tns run command never terminates. That is, you cannot type in your terminal or command prompt after your app starts up. This happens because the tns run command not only starts your apps, but it also watches your code for changes. When the tns run command detects a code change, the command automatically refreshes or live syncs your app so that you can see those changes immediately. Let's now make some updates to your code so you can see this in action. Open your new project in your favorite text editor or IDE. You can use any editor to develop NativeScript apps, but we recommend Visual Studio Code. We'll review Visual Studio Code later in this chapter. While this is live syncing, I can open up a new tab by hitting Command-T on the Mac in the terminal, which will keep me in my Hello World project directory, where I can launch my editor. Let's add a simple image to your app so you can see how live sync works. Open your app's main-page.xml file and place the following line of code directly under the comment, "Your UI components go here." Don't worry about the specifics of how this code works yet. We'll cover the details momentarily. For now, just get comfortable with how live sync works. I'm going to start my Android emulator as well so we can see the live syncing going on there. Now I'm live syncing both the iOS app and the Android app. The emulator refreshed and we see the new image. Next, let's animate the apple you just added. Open your app's app.css file and paste the following code directly below the line that says "Your CSS goes here." Again, don't worry about the details for now. I'm going to go ahead and save that, and when your emulator refreshes, you should see a crazy spinning apple. Let's make one final change. Find the first line of your app's app.css file. This import tells NativeScript to use a light color scheme. Let's change it to sky color scheme by replacing the existing line of code with this one. The emulator should refresh and you should see a nice blue action bar color. Looking for a little more fun? NativeScript has several color schemes available for styling your iOS and Android apps. Pick a different style sheet from the full list and try it out in your app. You can find the full list in the documentation under User Interface and then Theme. Scroll down to where it says Color Schemes and take a look at what's available. Overall, the NativeScript CLI's live sync process makes native iOS and Android development feel a lot like web development. You have the ability to change your CSS, markup, and JavaScript code, and see those changes reflected on the fly, all in a completely native mobile app. Now, a bit of warning, there are situations where you'll need to stop tns run and rebuild your app from scratch. For instance, if you need to install a new dependency from npm. In those cases, you'll need to type Control-C in your terminal to stop the current tns run process. Then you'll need to re-execute the tns run Android or tns run iOS to get your app up and running again. Don't worry though, when situations that require a restart come up in this tutorial, those instructions will be explicitly listed. You now know how to create and run NativeScript apps. Your next step is learning how to debug your apps when things go wrong. Let's look at how debugging works in NativeScript. One of the easiest things you can do to debug apps in any environment is using the system's log. In NativeScript, logging works a lot like it does on the web, as most of the same console APIs that work on the web also work in NativeScript. To see this in action, open your app's mainpage.js file and replace its contents with this code. After the NativeScript CLI refreshes your app, head back to your terminal or command prompt. You should see a Hello World message at the bottom that looks something like this. The console.log function is great for outputting primitive values such as strings, numbers, and booleans, but it doesn't work so well for objects. For those situations, you'll want to use another of the console object's methods intended for complex object output, console.dir. To see this in action, go back to your mainpage.js file and take a look at the console.log line. We're going to replace the hello world string with an object. This object has two properties, type and color. Let's save the file and take a look at the console. You'll see that console.log now prints out the actual object right here on the console. We still have console.dir available as we did before. If you use console.dir, I'm going to save the file and we take a look at the console, you'll see the same object being printed out down here, but now it's marked off with object dump start and object dump end, which is pretty helpful. The console.log and console.dir functions are two of the many tools available when debugging your NativeScript applications. You might want to try out step debugging as you move into more advanced development. But for now, let's shift our attention to how to deal with errors in NativeScript applications. Errors happen, and when they do, it's important to know how to handle them. Let's mess a few things up in your new app. Find the line of code that declares an action bar, right here. And from the end of the line, let's remove the greater than character. This is invalid markup, and as you might expect, NativeScript is unable to render your user interface. What NativeScript does do, however, is log any relevant errors and stack traces to your console. If you return to your terminal and scroll up just a little bit, you'll see the following error logged that indicates exactly where the problem is. As you can see here, we have a template parsing error and an unexpected character was found. Now, if you're on iOS, you'll see this message printed out to the terminal, but on Android, that doesn't happen. But if you take a look at the emulator, you'll see the same parse error in the emulator. Let's fix the error now by adding the greater than sign back to the end of the line in the action bar. The NativeScript CLI continues to watch the files in your application, even after errors. As such, after you correct this problem, the CLI updates your app to its previous state. Once you get started with the real-world application development, you'll almost certainly hit problems that are outside the scope of this basic tutorial. When you do hit these issues, the NativeScript community forum is a great place to get help. Now that you're familiar with how to create, run, and debug NativeScript apps, let's start building a real-world application. In the next chapter, you'll learn about how NativeScript apps are structured and start building a new app from the ground up. You can develop NativeScript apps in any text editor or IDE that you wish. Therefore, if you're deeply committed to an editor, by all means continue to use your editor of choice as you build applications with NativeScript. If you're a WebStorm user, check out this popular community-written plugin that adds a number of NativeScript-related features. You can find it at this URL. However, if you're not absolutely committed to an editor, or if you're looking to try something new, the NativeScript team recommends using Microsoft Visual Studio Code to develop your NativeScript applications. And here's why. Visual Studio Code has excellent support for TypeScript, which you may wish to use as an alternative to JavaScript for your NativeScript development. Visual Studio Code gives you the ability to debug JavaScript and TypeScript code directly in your editor. The NativeScript team maintains an official NativeScript Visual Studio Code extension that enables step debugging for NativeScript apps. Visual Studio Code is fast, and it's a modern editor that Microsoft updates very frequently. It's also available for Windows, macOS, and Linux. And of course, it's backed by Microsoft, so you can feel confident that the editor will continue to be supported in the future. If you do choose to use Visual Studio Code, let's look at a tip you can find useful as you develop NativeScript apps. After you install Visual Studio Code, you can open projects using the editor's File, Open menu option, but there's an alternative option that works far better for command line-based projects like NativeScript, the code command. The code command runs in your command line or terminal, and it works just like the TNS command does for NativeScript apps. Visual Studio Code installs the code command by default on Windows and Linux, but on macOS there's one manual step you must perform. You can find the instructions for setting this up at this address. The instructions here will guide you through installing the extra shell command. Once set up, you can type code dot in your terminal to open the files in your current folder for editing. For example, you could use the following sequence of commands to create a new NativeScript app and open it for editing. TNS create myNewApp will create a new NativeScript application called myNewApp. Then we can switch to our project directory myNewApp, and we can run the code dot command to open this new app folder in the Visual Studio Code editor. In this chapter, you're going to learn how to build NativeScript user interfaces, including markup, styling, images, and more. But to do that, you're going to start on a new app that you'll continue building throughout the rest of the tutorial. Working on a real-world app will help teach concepts that are hard to show in simple examples, such as how to best organize your code. With that in mind, let's start by looking at what you'll be building. We're going to look at building the Groceries app using pure NativeScript. In this chapter, we're also going to look at directory structure, adding UI components, layouts, CSS, and finally, we'll take a look at images. Let's get started. The rest of this guide will walk you through building Groceries, a groceries management app that does the following things: connects to an existing RESTful service, provides user registration and login, authenticates users and lets them add and delete groceries from a list, and it runs cross-platform on iOS and Android. If you follow along to the end, here's what the finished app will look like on iOS, and here's what the app will look like on Android. Let's get the starting point of this app so you can follow along with the rest of this guide. Your first step will be to find a place on your development machine to store this new project. You might want to set up a folder structure that looks something like this. On my machine, I have the code folder, and there's the Hello World app that we created earlier. I'm going to keep putting new projects in the code folder. Once you have a folder structure you're comfortable with in place, navigate to the folder using the terminal's cd command. Now for the rest of this lesson, please watch the lesson, and you can even perform the steps. But once you're done with the final step that creates a Groceries app from a project template, remove that folder and instead use the Groceries app project that is downloadable as a zip file below. The download has been updated to NativeScript version 6, whereas the template hasn't been. So make sure you use the download. Okay, so just as an example, if the template had been updated to NativeScript version 6, this is what you would have done. TNS create Groceries, and this will create a new project for you named Groceries in the Groceries folder, and it's a new NativeScript project. You've seen this before earlier in the course. We did this with Hello World. Now that you have the app locally, let's take a look at the files that make up this application. To keep things simple, let's start by looking at the outer structure of the Groceries app. First, go back to your terminal and let's go ahead and build this project. The command for that is tns build and then the platform. So tns build iOS will build for iOS, and this will take a few seconds to do. And that's completed. Now I'm going to build for Android. So I'm going to run tns build Android. The Android build takes a little bit longer, so be patient. Now that we have both iOS and Android built, let's go back to Visual Studio Code and we'll take a look at the folders. Here's what these various files and folders do. The app folder contains all the development resources you need to build your app. You'll be spending most of your time editing files in here. The Node Modules folder contains your app's npm module dependencies. All new NativeScript projects start with a single dependency on TNS Core Modules. Let's take a look at that folder. The TNS Core Modules folder contains your app's NativeScript Modules, which are a series of NativeScript-provided JavaScript modules you'll use to build your app. Each module contains the platform-specific code needed to implement some feature, HTTP calls, the file system, and so on and so forth, all exposed through a platform-agnostic API. For example, the HTTP getJSON function is exposed through this HTTP module, which is a cross-platform module. We'll look at some more examples in Chapter 4. The source code for these modules is all open source and lives in the NativeScript GitHub repository. The Platforms folder. This folder contains the platform-specific code NativeScript needs to build native iOS and Android apps. The reason we ran TNS build for iOS and Android in the beginning of this lesson is to generate the Android and iOS folders in this platform folder. In the Android folder, you'll find things like your project's manifest file and the APK executable and the Gradle files. Similarly, in the iOS folder, you'll see the Groceries Xcode project and the .ipa executable. Note, users on Windows and Linux machines will not have an iOS folder. The package.json file contains your app's configuration details, such as your app ID, the version of NativeScript you're using, and also which NPM modules your app uses. We'll take a closer look at how to use this file when we talk about using NPM modules in Chapter 5. One more note about the Platforms folder. The NativeScript CLI manages this Platforms folder for you as you develop and run your app. Therefore, it's best practice to treat this folder as a generated code folder. The Groceries app includes the Platforms folder in its gitignore file to exclude its files from source control. Next, let's dig into the app folder, as that's where you'll be spending the majority of your time. Here's what these various files and folders do. This app_resources folder contains platform-specific resources such as icons, splash screens, and configuration files. The NativeScript CLI takes care of injecting these resources into the appropriate places in the Platforms folder when you execute TNS run. This shared folder is specific to the Groceries app. It contains any files you need to share across views in your app. In the Groceries app, you'll find a few view model objects and a config.js file used to share configuration variables like API keys. The Views folder contains the code to build your app's views, each of which will have a subfolder in Views. Each view is made up of an XML file, a JavaScript file, and an optional CSS file. The Groceries app contains 3 folders for its 3 views. This app.css file contains global styles for your app. We'll dig into app styling later in this chapter. The app.js file sets up your application's starting module and initializes the app. Let's take a look at this app.js file, as it's the starting point for all NativeScript apps. Your app.js file contains the 2 lines shown here. Here, you're requiring or importing the NativeScript application module, and then you call its start method with the starting screen of your app, in this case, the login screen, which lives in your app's views login folder. Here's a tip. JavaScript modules in NativeScript follow the common JS specification. This means you can use the require method to import modules, as done here, as well as use the export keyword to expose a module's properties and methods, which we'll look at later in this chapter. These are the same constructs Node.js uses for JavaScript modules. So if you know how to use Node.js modules, you already know how to use NativeScript modules. Now that your app is ready for development, let's add some UI components to make your login screen show more than just some basic text. Let's dig into the files used to create your app's UI, which reside in the Views folder. Each folder inside the Views folder contains the code for one of the 3 pages in Groceries: List, Login, and Register. If you look in the Login folder, you'll see 3 files: login.css, login.js, and login.xml. When you open login.xml, you should see the following code. This page currently contains 2 UI components, a page and a label. To make this page look more like a login page, let's add a few additional components, namely 2 text field elements and 2 button elements. Open up the login.xml file and replace the existing label with this code. NativeScript UI components provide attributes to let you configure their behavior and appearance. The code you just added uses the following attributes. For text field, we have a hint attribute, which shows placeholder text that tells the user what to type. The keyboard type attribute determines the type of keyboard to present to the user for input. In this case, we have email. Keyboard equals email shows a keyboard optimized for entering email addresses. NativeScript currently supports 5 types of keyboards for text fields. The autocorrect attribute is a Boolean attribute that determines whether the mobile operating system should autocorrect user input. In the case of email address text field, the autocorrect behavior is undesirable. Auto-capitalization type. This attribute determines how the operating system should auto-capitalize user input. When we have it set to none, such as here, it turns auto-capitalization off altogether. NativeScript supports 4 auto-capitalization types on text fields. This secure attribute is a Boolean attribute that determines whether the text field text should be masked, which is commonly done on password fields. Now, for both buttons, we have a text attribute, which controls the text displayed within the button. I'm going to go ahead to the terminal and run this app in iOS and in Android. I have 2 tabs open in my terminal, one for iOS and one for Android, and I'm going to issue the tns run command on each one. Make sure you're in the Groceries project folder before executing the run command. After your app launches with this change, you may expect to see a polished login screen, but instead you'll see a single button element on the screen. Currently, you only see this single button because you need to tell NativeScript how to lay out your page's UI elements. And we'll do that in the next lesson. NativeScript provides several different layout containers that allow you to place UI components precisely where you want them to appear. The absolute layout lets you position elements using explicit X and Y coordinates. This is useful when you need to place elements in exact locations. For example, showing an activity indicator widget in the top left corner of your app. The dock layout is useful for placing UI elements at the outer edges of your app. For example, a container docked at the bottom of the screen would be a good location for an ad. The flexbox layout lets you arrange UI components just like you do on the web with Display Flex. The grid layout lets you divide your interface into a series of rows and columns, much like a table in HTML markup. The stack layout lets you stack child UI components either vertically or horizontally. And finally, the wrap layout lets child UI components flow from one row or column to the next when space is filled up. For your login screen, all you need is a simple stack layout to stack the UI components on top of each other. In later sections, you'll use some of the more advanced layouts. Let's add a stack layout to the login screen. Open up your login.xml file and add a stack layout component within the page component. The stack layout is a UI component, and as such, it has attributes just like the text field and button components that we've talked about in the previous section. Here, if we set the orientation to vertical, this attribute will tell the stack layout to arrange its child components vertically. After you run your app with this change, or if you have it live syncing, which the tns run command will automatically do for you, you'll see that your login page's UI components stack up. Although the UI components are in the correct order, they could use some spacing and color to make the app look a little bit nicer. And to do that, let's look at another NativeScript feature, CSS. We'll take a look at CSS in the next lesson. But here's another tip. You can refer to the NativeScript docs at this URL for a look at how NativeScript layouts work and the various things you can do to configure them. You can also check out Jen Looper's article on demystifying NativeScript layouts for a thorough look at NativeScript layouts in action. NativeScript uses a subset of CSS to change the visual appearance of your app. You can use 3 mechanisms to add CSS properties to a UI component. Application-wide CSS in the app.css file, page-specific CSS, and inline style attribute. You should place CSS rules that should apply to all pages in your app.css file, and CSS rules that apply to a single page in a page-specific CSS file. For example, login.css. And although inline styles are great for quick testing, you should avoid them in general because the style attributes tend to clutter up XML files, especially if you need to apply multiple rules. For example, here in the login page, we can add a style attribute and we can set background color to green. As you can see here, our background color in the app is now green, but now we have a messy XML file, so let's take that out. Try to keep your CSS in CSS files. Let's start by adding a few application-wide CSS rules. Open up your app.css file and add the following code to it. If you've done any web development before, the syntax should feel familiar here. You select 4 UI components, page, text field, image, and button, by their tag name, and apply a handful of CSS rules as name-value pairs. NativeScript does not support all CSS properties because it is not possible to replicate some of them in native apps without causing performance issues. A full list of CSS properties that are supported are listed in the NativeScript docs. Let's make one more change. Although often you want CSS rules to apply equally to your iOS and Android app, occasionally it makes sense to apply a CSS rule to only one platform. For example, iOS text fields frequently have borders around them, but Android text fields do not. Let's look at how to make platform-specific style changes in NativeScript. At the top of this file, we're going to add an import statement, and we're going to import platform.css. Here you can see that NativeScript is consistent with browser implementations in that import statements must precede all other CSS rules in a file. Next, open up your login.xml file again and add a class to this button here called link. Let's break down what just happened. First, NativeScript supports CSS's import statement for importing one CSS file into another. So this new line of code imports the CSS rules from platform CSS into app CSS. But you might have noticed that Groceries does not have a file named platform.css, only platform.android.css and platform.ios.css. What's going on here? Well, when you execute tns run, the NativeScript CLI takes your code from the app folder and places it in the native projects located in the platform iOS and platform Android folders. Here, the naming convention comes in. While moving files, the CLI intelligently selects .android.star and .ios.star files, so any files with Android in them and iOS in them. To give you a specific example, the CLI moves this platform.ios.css file into the iOS folder in the platforms folder, but it renames it to platform.css. And similarly, the CLI moves the platform.android.css file into the platform's Android folder, and again it renames it to platform.css. This convention provides a convenient way to branch your code to handle iOS and Android separately. And it's supported for any type of file in NativeScript, not just CSS files. You'll see a few more examples of this convention later in this guide. There's one other change here we need to discuss, and that's the class attribute you've added to the button. NativeScript uses the class attribute for adding CSS class names to UI components. The class name is used to give the sign up button a slightly different look than the sign in button. You can find the CSS rules associated with this class name in platform.ios.css and platform.android.css. With these changes in place, you'll notice that the app looks halfway decent now and also has a distinctly different look on iOS and Android. Feel free to take time to play with the look of this app before moving on. You can try adding some additional CSS class names or adding some page-specific styles in your login.css file, and when you're ready, you'll move on and add an image to the login screen. We'll do that next. In NativeScript, you use the image UI component and its src attribute to add images to your pages. The src attribute, or source, lets you specify your image in three ways. The first and the simplest way is to point at the URL of an image, like so. The second way is to point at an image that lives within your app's app folder. For example, if you have an image in the images folder inside the app folder, and it's called logo.png, you can use it like so. The third way, and the one Groceries uses, is to use platform-specific image resources. Let's add an image to the login screen and then discuss exactly what's happening. If you don't already have it open up the login.xml file and add the image as the first child of the existing stack layout tag, like so. The res:// syntax tells NativeScript to use a platform-specific resource, in this case an image. Platform-specific resources go in your app's app resources folder. If you look there right now, you'll find a few different image files, several of which are named logo.png. Although more complex than putting an image directly in the app folder, using platform-specific images gives you more control over image display on different device dimensions. For example, iOS lets you provide 3 different image files for devices with different pixel densities. And as such, you'll find logos named logo.png, logo at 2x.png, and logo at 3x.png in your app resources/iOS folder. And for Android, you'll find similar image files in the drawable MDPI for medium DPI or medium dots per inch, in the drawable HDPI for high DPI, and the drawable XHDPI for extra high DPI, and so forth. Once these files are in place, the NativeScript framework knows how to pick the correct file. All you have to do is reference the image using res:/ and its base file name. So here you see we're using res:/ logo without the PNG. If you take a look at the app now, you'll see that the login screen now has a logo. Here's a tip. The community-written NativeScript Image Builder is a tool that can help you generate images in the appropriate resolutions for iOS and Android. You can find it at this URL. At this point, your UI looks good, but the app still doesn't actually do anything. Let's look at how you can use JavaScript to add some functionality. In this chapter, you'll learn how to add JavaScript logic to your NativeScript app, and you'll be doing so using the base pattern on which NativeScript framework is built, MVVM, or Model View View Model. Here's what those words mean. The model defines and represents the data. Separating the model from various views that might use it allows for code reuse. The view represents the UI, which in NativeScript is written in XML. The view is often data-bound to the view model so that changes made to the view model in JavaScript instantly trigger visual changes to UI components. The view model contains the application logic, often including the model, and exposes the data to the view. NativeScript provides a module called Observable, which facilitates creating a view model object that can be bound to the view. The biggest benefit of separating models, views, and view models is that you're able to use two-way data binding. That is, changes to data in the model get instantly reflected in the view and vice versa. The other big benefit is code reuse, as you're often able to reuse models and view models across views. In Groceries, so far, you've only touched the view login.xml, and in this chapter, you'll be creating a view model. To do so, we first need to introduce one other type of file, the code behind file. So in this chapter, we'll be looking at the code behind, we'll be looking at navigation screens, accessing UI components, and adding a view model. Let's get started. In NativeScript, a code behind file is a JavaScript file that shares the same name as the view. For example, the login page's view is named login.xml, so its code behind is named login.js. The code behind file is where you put all code that interacts with the view itself. Let's look at what you can do in a code behind file with a simple example. If you don't already have it open up the login.xml file. And now add the loaded attribute to the page UI component at the top. It should look like this. Next, open up the login.js file, which is sitting right next to the XML file, and add the following code. It defines a loaded function. Just a note here, the keyword exports is part of CommonJS, the standard on which both NativeScript and Node.js implementations of modules are based. In CommonJS-based JavaScript modules, a free variable called exports is an object to which modules might add properties and methods to configure its external API. Using exports in a code behind file exposes the function for use in the view or XML file. That is, the exports.loaded assignment in the code behind file here is what makes loaded equals loaded in the view work. When you run the app with this change, NativeScript triggers the loaded function you created in the code behind file, and you should see the word hello in your terminal. This simple example shows how you can append attributes to UI components to run functions in the view's accompanying JavaScript file, or the code behind. Let's use another one of these attributes. We'll use tap in this case. You can add a tap attribute that will fire when the user taps or touches a button. In the login.xml file, there are two buttons at the bottom. We're going to add tap events to each one of them. To the sign-in button, add the tap attribute, and it's going to call the sign-in function. And to the sign up for groceries button, we're going to add a tap attribute that calls the register function. Now go back to the login.js, and at the bottom here, we're going to add the sign in function and the register function to the exports. At this point, if you run your app and tap either of the buttons, you will see the appropriate alerts pop up. Now that you see tap gestures working, let's make them do something more interesting than open alerts. We'll do that next. When you tap the Sign Up for Groceries button, you would expect a navigational change to a register screen. This is very easy to do in NativeScript. Let's enable the Sign Up button on the login screen with a navigation change. Open up your login.js file and add this line at the top of the file. Then, inside the register function, remove the alert and instead add this code. This function uses the NativeScript frame module, which comes with NativeScript, and it's responsible for navigation in your app. Here you tell the topmost frame, the frame the user actually sees, to navigate to the register view. If you run your app now and tap the Sign Up for Groceries button, you will be sent to the registration screen, which we have pre-built for you. Now that you can access the registration page, go ahead and sign up for an account to use for the rest of this tutorial. You can provide an email address and password and tap the Sign Up button to create an account. You can use a fake email address and password. Just remember your credentials as you'll need them later. Although your Groceries app doesn't use complex navigation strategies, you have several available to you out of the box, such as the tab view and the segmented bar UI components. And a side drawer component is also available for free via Telerik's UI for NativeScript product. In the next lesson, we'll take a look at accessing UI components. It's time to see how data flows back and forth between the front end and the back end in forms. Let's send data from the front end to the view model. Open your login.xml file if you don't already have it open, and add the ID equals email attribute to the email text field. With an ID attribute in place, you can access this text field in your code behind file. To do that, start by opening up the login.js file and add these two lines of code at the top of the file, right underneath the frame module import. Next, edit the loaded function in your login.js file to get a reference to the current page. We're going to add the args here that get passed in the loaded event and remove this console.log, and args.object here will be our page. So let's save that off to the login page's page variable. This works because NativeScript passes loaded event handlers a reference to the page in a function's argument, which is named args by convention. Finally, edit the sign-in function to get a reference to the text field component and log its contents. Let's remove this alert, and we're going to use the page's getViewById function to get a reference to the text field with an ID of email. And finally, we're going to log to the console the text attribute of the email text field. All NativeScript UI components, including page, inherit from the view class, which gives them a number of methods for working the UI. In this case, you use the getViewById method to get a reference to the email text field by its ID attribute. To see how this works in action, run the app, type some text in the email address text field, and tap the Sign In button. If all went well, you should see the text you typed logged into the terminal. By accessing UI elements in JavaScript, you can control how those elements look and behave on the front end. However, accessing these UI components individually is a very manual process, and it makes it hard to track the state of the UI. This is where the view models come in handy, and we'll take a look at that next. NativeScript provides a view model functionality in the form of a module called Observable. The Observable is a view model in the MVVM design pattern. It provides a mechanism used for two-way data binding to enable direct communication between the UI and code behind file. This means that if the user updates the data in the UI, changes will be automatically reflected in the view model, and vice versa. Let's create a view model and bind it to the view. To allow for two-way data binding using an observable, open the login.xml file if you don't already have it open, and include the text attribute in each of the text fields that we have. Note the use of the curly braces around the text attribute's value. It delineates the data-bound value. Make sure there are two of them on each side. You will be setting corresponding properties with the same name in the view model. Now open up your login.js file, and at the top, right below the frame module, we're going to require the observable module. The code gets a reference to the observable constructor from the observable module and invokes the constructor to define a new user object, which you'll be using as this page's view model. The observable module provides a handy FromObject method to call the constructor internally and give us the object. It's like a factory function. Now go to the loaded function, and right under the page equals args equals object call, we're going to set the binding context of the page to the user that we created. So what's going on here? We're creating a user view model that is based on the NativeScript observable module. You create the view model with two properties, email and password, and they're pre-populated with some dummy values here. Next, you bind the page to the user view model by setting it as the page's binding context property. This is specifically what makes the curly braces syntax work. Simply put, properties placed on the page's binding context are available to XML elements using the curly braces syntax. Because JavaScript sets the view model's email to user@domain.com, and because you bound the email address text field to that property using the text attribute of the text field, when you run your app, you'll see user@domain.com appear on the front end. Right now we have password in the user field, so we must have done something wrong. Let's take a look at the login. Ah, yes. I have this text field twice in here. Let me move the second one down to the password text field. And now that we take a look at the app, we have user@domain.com and the password pre-populated into our text fields. What's really cool here is the binding is two-way, meaning when the user types text into these text fields, those changes are immediately applied to your view model. To use these values and to make this login functional by typing your app into a backend service, you're going to need the ability to make HTTP calls. And to make HTTP calls in NativeScript, you use NativeScript Fetch module. Let's look at how NativeScript modules work in the next chapter. In this chapter, you'll learn about NativeScript modules, which are the JavaScript modules in your app's Node Modules TNS Core Modules folder. Whether you've realized it or not, you've already used several NativeScript modules. This includes the modules you've brought in via the require call, the view, the frame, and the observables modules that we've used previously, and also the UI components you've been using in XML, the page, image, text field, and button modules. In Chapter 4, we're going to be talking about connecting to a backend. We're going to look at the Dialog Module. We're going to look at a very common UI component called the list view, which also comes as a module. We're going to work with arrays. We're going to look at a new layout called the grid layout. We're going to use the activity indicator, and finally we'll look at animations. If you dig into your Node Modules TNS Core Modules folder, you can get an idea of how these modules work. Start by finding the Node Modules TNS Core Modules color folder, which includes the implementation of the color module. It includes a package.json file that's the name of the module, a file containing the module's Android implementation, color.android.js, a file containing the module's iOS implementation, which is color.ios.js, and a file containing the code shared by the Android and iOS implementations called color-common.js. The star.ios.star and star.android.star naming conventions should look familiar, as it's the exact same convention we use to include Android and iOS specific styling in Chapter 2. NativeScript uses this same convention to implement its modules on iOS and Android. Now that you know where these modules are, let's take a closer look at what else they can do for your app. When you created your own account on the registration page, you probably noticed that data was magically going somewhere, but there's actually no magic involved here. The register page invokes a RESTful API provided by Telerik Backend services to register the user for the Groceries service. Now, you don't have to use Telerik Backend services to hit your backend service. You can use any HTTP API in a NativeScript app. Telerik Backend services is just convenient to use for this tutorial because it lets us spin up HTTP endpoints quickly. Take a look at the config.js file in the shared folder in your app. There's only a small code snippet there, but it includes a hard-coded route path to the Groceries backend that the register page uses, and that you'll be using momentarily. The config.js file also happens to show a convenient pattern that you can use for sharing configuration variables throughout your app. Next, let's take a look at the view models folder here. I'm going to open this up a little bit more. This folder contains a few view models that we've prepackaged into Groceries, and those view models contain the code to hit our backend. You can see this demonstrated in the user view model.js file in the register function. In a larger app, it's pretty common to place code that interacts with the backend in separate files and not directly in view models. But in our case, the connection code lives directly in the view model for simplicity, which is perfectly reasonable for small apps. Note that the register function here uses the config module to get a path to the backend, as well as the fetch module to make actual HTTP calls. You can see at the top of this file we're importing the config and the fetch module. NativeScript's fetch module uses the same API as the browser's new fetch API. Therefore, if you already know how to use the web's fetch method, you already know how to make HTTP calls in NativeScript. Let's look at how the fetch module works by adding another method to the user view model. We already have the register function here, but we don't have a login function yet, so we need to go ahead and create that. I'm going to paste in the login function code here. You can either type it in from viewing in this video, or you can get it from the NativeScripting code repository for this course, which is on GitHub. The link to the repo is below. Once you'll go to the repo, you'll find the login function that we're looking for in chapter 4, 401 end. That's the state of the groceries project at that lesson. App, shared, view models, user view model, and if you scroll down a little bit, there's the login function that we're looking for. For the rest of this course, I'm going to copy long sections of code like this from the repository. I suggest you clone this repo just to make this easier for you. And there's our login function. Now let's break down what the code you just pasted in does. First, you'll use the fetch module's fetch method to post data to the API URL stored in the config.js file. The username, password are sent to this endpoint as a JSON string. The fetch method returns a promise, which allows you to execute code after the asynchronous login either completes successfully or fails. You use this functionality to do three things. There are three then handlers here, as you can see. First, you handle any errors in the HTTP response with the handle errors function defined at the bottom of the user view model. Next, you convert the return data into a JSON object by calling the response object's JSON method. And finally, you save the reference to the user's authentication token in the config module. You'll use that token on subsequent HTTP requests later in this guide. By the way, promises are part of ECMAScript 6, and because promises have been implemented in the two JavaScript engines NativeScript uses, V8 for Android and JavaScript Core for iOS, promises are available for use in NativeScript apps. And NativeScript makes fetch available as a global variable for convenience. So you could replace the fetch module.fetch call with just fetch. The global fetch shortcut will be used for the remainder of this guide. Now with this code in place, let's return to the login.js file to use this new function. Open up your views login.js file, and at the very top of the file, add the reference to the shared view models user view model file. We will no longer need this observable module or this user object, since we'll be using the user view model instead of the user you added in the previous chapter. So right up here, we're going to add a new user object, and we're going to instantiate the user view model that we've imported. And finally, in the sign-in function, let's remove all the code inside, and we're going to use the user object. We're going to call the login function on it. Just take a moment to look at how clean your code behind file is now. The code behind instantiates a view model, which is the user view model, and calls its login method when the user taps the view's sign-in button. Because the view model is bound to the page's two text fields, remember email and password are data bound, the view model already has the data it needs to perform the actual login. And if you try running your app and input your account's credentials, you can indeed log in, but you don't see anything. That's because view models aren't responsible for updating the UI. Instead, the view model returns a promise to let the code behind handle the UI. Remember that fetch returns a promise. Let's see how you can use that promise and introduce a new NativeScript module in the process. To utilize the promise that the view model's login function returns, you need to handle two scenarios: what to do when the login works and what to do when it doesn't. In the case of groceries, when the login works, you're going to navigate the user to the list page, which you'll be building momentarily, and which lets the user add and remove groceries from the list. To perform the actual navigation, you'll use the same frame module you used earlier in this guide. Now the trickier situation is handling login failures. And for that, you're going to use the Dialog Module. You can use this module to show several types of pop-up UIs in your app, including action sheet, confirmation boxes, alert boxes, and prompts. It is a highly customizable module, and it lets you control the buttons in your alerts, the text, and the messaging in the alert itself. The Dialog Module's code is in the Node Modules TNS Core Modules/UI folder with other UI widgets. Let's see how you can use this widget on the login screen. Open up your login.js file if you don't already have it open, and import the Dialog Module. Next, we're going to update the sign-in function to handle the promise that gets returned by the login function and its error and success conditions. This is one of those cases where you can go to the documentation and copy the code for the sign-in. This code handles both a successful and unsuccessful login. On success, you call the frame module's navigate method to navigate the user to the currently empty list page, and on failure, you will use the dialog module to show the user an error message. Try inputting some invalid credentials to see what the dialog looks like. And with that, the login page is completely functional. Now that you have the user management working in your NativeScript app, let's move on to the page where users will manage the grocery list itself. To do that, you need a module that shows items in a list, which is exactly what the ListView module does. Now just a tip, from this point forward in this course, we'll have to log in a lot. So you may find it helpful to hard code your credentials in the app during development. The easiest way to do that is to pass an email address and password that you've registered with to the user view model constructor. Let's do that here. So we're going to pass in the email and the password. And let's sign in with that information. And we are in. We just have an empty list, which we'll handle next. The List View widget lets you show a list of things on the screen, which is exactly what you need for showing a list of groceries. Before tying the grocery list to a backend API, let's start by seeing how to show a hard-coded list of items on the screen. Let's construct the list view. Open up your list.xml file and add the following code, which creates the list where your groceries will reside. Notice that this page is going to use a grid layout to lay out the UI components on the screen. As you add more UI components, you'll start dividing the screen into rows and columns. But for now, you're just going to let the list view take up the full screen, which is the default behavior of a grid layout with no attributes. As discussed earlier, even though you're using list view in XML, the list view module is still a NativeScript module. You can find its implementation in the Node Modules TNS Core Modules UI list view folder. If you want to, you can construct the list view in pure JavaScript code in the code behind file, as shown in the example at this URL. Go down to about halfway through the page, and you'll see an example of creating the list view. Now, for most situations, using the NativeScript UI modules in XML is easier, so we'll be sticking with XML usage throughout this tutorial. Notice the use of the listview.item template. This tag gives you the ability to control how each of ListView's items displays in the list. For now, you're using a simple label UI component to display the name of each grocery. If you run this code as is, you won't see any items in the grocery list. First, you need to build out a way to manage data within the ListView module. And to do that, you're going to need a NativeScript module called Observable Array. We'll take a look at that in the next lesson. In the previous lesson, you saw how to create observables and how to use them to connect XML views with code behind files and view models. You're going to do the same thing in this lesson with one additional twist. It involves making this items attribute work. The ListView module's items attribute takes an array, and to create that array on the view model, NativeScript provides a special observable array module. To see how this works, let's start building the list page's code behind file. Open up the list.js file, which is our code behind for the list page, and add the following code. Here, you're creating a new observable called pageData, which you set as the page's binding context in the loaded function. You've seen this before. Inside the observable, you set a single grocery list property to the new instance of the observable array class. Notice how the grocery list property corresponds to the ListView items grocery list binding, and each array entry's name property corresponds to the label text binding, which is bound to name. Notice how this example uses the observable module's FromObject method instead of the observable class constructor. Both the FromObject and newObservable create a new observable instance. However, FromObject method performs a bit of additional initialization to handle nested objects. This example uses FromObject because the pageData observable object contains a nested observable array. If you run your app now, you'll see the list screen shows the hard-coded data. Now that we have items on the screen, let's take a look at how you can tie this to the backend instead of the hard-coded data. To do so, you'll switch the list page to use a view model, much like you did with the login page. A starting view model for this page is already in the file grocery list view model in the view models folder. If you take a look at this file, it contains the code that looks a lot like what you already have in list.js. Let's expand on this to tie this view model to a backend. First, let's go back to list.js, and we're going to use the grocery list view model here. At the top, let's go ahead and import the grocery list view model. Let's remove this right here, this page data. We don't need that anymore because it's hard-coded. And in the same location, let's add an initialization of the grocery list view model. And we're going to pass in an empty array to initialize it. And the new page data variable is going to use the Observable Module from object function, passing in the grocery list as one of the properties of the object. Finally, we're going to add a couple of calls here to the loaded function at the bottom, which calls two methods of the view model, empty and load. In this code, grocery list is referencing the grocery list model, the view model, and the empty function empties the list, and then calls the model's load function to reload the data from the backend. The last piece to make all this work is actually implementing the empty and the load functions in the view model. Open up the grocery list view model file if you don't already have it open, and add the following code between the var view model assignment and the return view model statement. This defines the load function and the empty function. The code to make an HTTP call should look familiar, as it leverages the same fetch module you used in the previous section. And just like previously, the fetch module's first then handler checks for HTTP errors, the second then handler converts the data from the response into a JSON object, and the third handler pushes each grocery item from the response onto the observable array. The cool thing here is the code you didn't have to write. Notice there is no need to refresh the UI or manually access the list view UI component. All the view model does is push the JSON response to the observable array, and the UI takes care of itself. If you load the list page with the account you created earlier, you'll see a blank page, as your account is newly created and therefore your grocery list is empty. To really test out these changes, you'll need to allow users to add groceries to their lists. So let's look at how to do that next. You already know how to add items to the list view because you just did so in the previous lesson. All you need to do is call the Observable Array Modules push method. To give the user the ability to manage their grocery list, you're going to have to put some more UI components on the screen. And to do that, you're going to need to divide the screen into rows and columns using the grid layout UI component. Let's implement the ability to add groceries to the list. If you don't already have it open up the list.xml file where you have the grid layout and add the following attributes to the grid layout tag. Rows, we'll set that to auto, star, and columns. We'll set that to 2 star, star. Here, the rows attribute divides the screen into 2 rows. The first row is auto-sized according to its children's height, and the other to contain star, or the remaining height of the screen. The columns attribute divides the screen into 2 columns, where the first column takes up 2/3 of the screen, and the second takes up the remaining third. Next, to give the user a means of adding groceries to the list, add a text field and a button to the page. So let's add these 2 lines of code directly after the initial grid layout opening tag. The text field has an ID attribute of grocery and is bound to the grocery property of the page's binding context. The button's tap event refers to an add function. You'll add this to the code behind momentarily. But the most important thing here to note is the use of the row and col attributes. These attributes are 0-based, so the text field's row equals 0 and col equals 0 attributes place it in the first row and in the first column, whereas the button's row equals 0, col equals 1 attributes place it in the first row and second column. Finally, we're going to need to place this list view somewhere in the grid so it doesn't overlap with the button and text field. So let's add a few attributes to this list view tag. First, we're going to add the ID attribute, which we're going to use later. And we're going to position this list view in row 1 of the grid layout. And we're going to also use the call span attribute to span 2 columns. Now you just need to make the necessary changes to the code behind file to support these XML changes. If you don't already have it open up the list.js file and start by adding a new grocery property to the page data observable. The page data assignment should look like this now. Next, we need to add the add function to handle the button tap event. insert this code at the bottom of list.js. In this function, you'll first ensure the user didn't submit without typing a grocery. If the user did type something, you dismiss the device's keyboard, then you get the grocery property from the page's binding context, which is bound to the new text field, and pass that value to the viewModel's add function. Finally, let's define the add function in the grocery list viewModel. Open up the grocery list viewModel file, and just under the empty function here, right before the return viewModel statement, right here, we're going to insert the new add function. Now, if you build and rerun your app, you'll find that you can add a grocery item and it will appear immediately in your list. And all of this is completely driven by a backend service. Pretty cool, huh? In the next lesson, we'll look how you can polish this page with a NativeScript module for showing activity indicators. Currently, there is a bit of a delay when you first visit the list page before groceries appear. This delay could confuse a new user who might think the app is stuck rather than retrieving data from a backend. In NativeScript apps, you can use the Activity Indicator module to show a spinner icon in your UI while your app is busy performing actions. The Activity Indicator is a relatively simple UI element as its primary use has one attribute: busy. When an Activity Indicator's busy attribute is set to true, the Activity Indicator shows, and when its busy attribute is set to false, it doesn't. Let's see how the module works by adding an activity indicator to the list page. Open up your list.xml file if you don't already have it open, and add this element directly before the closing grid layout tag. Then, in the list.js file, the code behind file, find the loaded event handler here, and find this grocery list.load call. We want to set the isLoading property to true. So page data, we're going to use the observables set function, and we're going to set isLoading to true. This grocery list.load function returns a promise, so we can call then on it, and when it's done, we can set the page data isLoading property to false. You add a new isLoading flag to the list page's observable, and then bind the activity indicator's busy attribute to that value. You set the initial value of the isLoading flag to true in the page's loaded function, which shows the activity indicator. And when the grocery list finishes loading, you flip the isLoading flag back to false, which hides the activity indicator. You can control where the activity indicator displays by setting its row span and call span attributes. In this case, row span equals 2 and call span equals 2 makes the activity indicator take up both rows and both columns of its parent grid layout. Here's what the new activity indicator looks like. The list page is now more user-friendly, but we can improve the experience with one more powerful NativeScript module, the animation module. Let's do that next. The ability to run robust and performant animations is one of the biggest reasons people choose to build native mobile apps in the first place, and NativeScript makes running these animations simple. The NativeScript animation modules provide a series of JavaScript APIs that let you perform a wide variety of animations to elements on the screen, including opacity, background color, translations, scaling, and rotation. For our list page, you're going to use an opacity animation to fade in your grocery list after your data loads. Let's add the code and then discuss how it all works. Open up your list.css file, which already has some styles. And in the list view selector, we're going to add the opacity 0 rule. Then go to the list.js code behind file and locate the loaded event handler. Remember that ID we added to the list view tag? Well, we're going to use it now. Let's go ahead and use the getViewById function of the page, which we've used before, and we're going to get a reference to the grocery list, which is a list view. Now, after we're done loading, we're going to use that list view and call its animate function, passing in some parameters. We're going to set opacity equal to 1, and we're going to set the duration to 1000 milliseconds, or 1 second. Now, a few things are happening in the code here. First, in CSS, you assign an opacity of 0 to the grocery list view. This hides the grocery list completely when the page loads. Next, in JavaScript, after the grocery list load call completes, you call the list view's animate function. This changes the element's opacity from 0, which is completely hidden, to 1, which is completely visible, in 1 full second. Now, the animation function's duration property takes a time in milliseconds. Therefore, 1000 equals to 1 second. The result of this code is a nice fade-in animation. The animation module is a lot of fun to play with, and it's easy to use. All you need to do is get a reference to an element using the getViewById function, and then call that element's animate method. You may want to take a few minutes to look through our animation samples and try a few of these animations for yourself in Groceries. You can find the animation samples at this URL. Now that you have the login, registration, and list pages complete, let's enhance the app's functionality as a grocery list management tool. In the next chapters, you'll add functionality such as email validation, social sharing, and more. And you'll use one of NativeScript's most useful features to do this, npm modules. By the way, there are several modules that come out of the box with your NativeScript installation that we did not have time to cover in this guide, including a file system helper, a timer module, and a whole lot more. Make sure to peruse the API reference of the NativeScript documentation, or just look around in your TNS Core Modules folder. You can also take a look at the premium course available right here, where we dive into these modules. All right, folks, hopefully that gives you a lot of introduction about NativeScript. For those of you that are still here, thank you very much for watching this. Now, you can get the rest of the course, there's a couple more chapters left, on nativescripting.com, and I'd appreciate it if you go over there, check out what's over there, because there's a lot of content that's free and a lot of content that's premium, all about NativeScript. So if you're into a NativeScript and you want to learn more about it, go check out nativescripting.com. Oh, and this is not a typical kind of video that I usually do on this channel. I usually do really quick, more advanced level type of tutorials here as well. If you like it, subscribe to the channel as well. Just hit on the subscribe button and the little notification bell so you don't miss any of those upcoming tutorials. Thanks again for watching this, and I'll see you next time. Happy NativeScripting!